What if I told you there was this clean, powerful, and pretty much limitless source of energy that's on 24/7, and it's not up in the sky or in the wind, but literally right under our feet? All right, let's get into the incredible potential of geothermal energy.
First off, let's just wrap our heads around the sheer scale we're talking about. The Earth's core, it's basically a natural nuclear reactor, and it's about as hot as the surface of the sun. Now get this. Just 0.1% of the planet's heat could supply all of humanity's energy needs for the next 2 million years.
So yeah, that's the big question, isn't it? If we have the safe, clean fission reactor already running right beneath us, why does geothermal make up such a tiny sliver of our energy supply? Why aren't we plugging into this planetary battery?
To really get the challenge here, we have to go back to the source. Geothermal energy is literally the heat that comes from the Earth's core. It's the planet's own built-in, self-recharging power pack. You've actually seen this energy in action, you probably just didn't think of it that way. You know, the same incredible heat that gives us geysers like Old Faithful or those amazing hot springs? Well, we can harness that exact same energy to generate clean electricity, day and night, all the time. So how have we been trying to do it so far? Let's take a look at the conventional methods, which you'll see are really just barely scratching the surface of what's possible. Right now, there are pretty much 3 main ways we make geothermal power. The simplest is called dry steam. You literally just have steam from underground that flows right to a turbine. Then there's flash steam, where you pump up super hot water, the pressure drops, and it flashes into steam. And finally, you have binary cycle plants, which use that hot water to boil a different liquid, and that vapor is what turns the turbine. But here's the catch. All of these methods only work in very specific, very rare places. Think Iceland or parts of California, where all that heat is unusually close to the surface. And that's the fundamental problem. Conventional geothermal can only get to a tiny fraction of the Earth's total heat. To really unlock geothermal for everyone, everywhere, we need to go deeper. A lot deeper. And that's where we run smack into a massive physical and technological wall. And it's just like scientist Gabriel Mayer says, our current tools are just not built for this job. As you drill down, the temperature and pressure ramp up like crazy. We're talking about 30 degrees Celsius and 25 megapascals for every single kilometer. You see, the rock itself completely changes the deeper you go. Near the surface, it's brittle, kind of like a chocolate bar that you can just snap into. But you go deep enough and that insane heat and pressure turn the very same rock ductile. It starts to behave more like fudge. It flows and deforms instead of breaking, which is a total nightmare for a conventional drill bit. And that brings us to this pretty wild mechanical challenge. Imagine trying to drill a hole by holding a 10-kilometer-long piece of spaghetti at the top and trying to rotate it. That's basically what we're doing with mechanical drill bits. Almost none of the energy you're using actually makes it down to the rock you're trying to cut. But what if we could just bypass all these problems? This is where things get really cool. A new generation of innovators are rethinking the whole idea of drilling, and their solutions sound like they're straight out of science fiction. The first key to unlocking this is something called supercritical water. When you get water hot enough and you put it under enough pressure, it enters this really weird state. It's not a liquid anymore. It's not a gas. It becomes something else entirely, something that is just incredibly dense with energy. So how much more energy are we talking about here? Using supercritical water could multiply the energy output of a single geothermal well by a factor of 10. I mean, that's a huge leap. That's what makes deep geothermal a real possibility. But to get down to that supercritical state, you need a totally new way to drill. So instead of slowly scraping and grinding away at rock with bits that are constantly wearing out, what if you could just vaporize it? That's the whole idea behind using high-power microwave beams to just blast through rock without ever physically touching it. And this isn't just a theory, by the way. Companies are already on it. You've got Quais Energy, which is developing these microwave drills to get down to 20 kilometers deep. And then you have Fervo Energy, which is taking horizontal drilling techniques from the oil and gas industry and using them to create these massive, man-made heat exchangers underground. So what does a future that's powered by this tech actually look like? Because this isn't just some small improvement we're talking about. This is a fundamental shift in how we think about energy. So right now, today, our world runs on about 80% fossil fuels. That massive slice of the pie, that's the whole problem we're trying to solve. That other 20% of clean energy, that's mostly hydro and nuclear. Now hold that 80% number in your head and listen to this vision from the CEO of Quasi Energy. The goal here isn't just to add geothermal to that little 20% clean energy slice. The goal is for it to replace the entire 80% that's currently dominated by oil and gas. Now, really, the only other clean energy source that can provide that kind of 24/7 baseload power is nuclear. But when you put them side by side, geothermal has some pretty clear advantages. You get the same small footprint and the same rock-solid reliability, but without needing all the extensive safety measures or dealing with the challenge of long-lasting radioactive waste.
So let's just put it all together. What we're talking about is a power source that is reliable around the clock, unlike wind or solar. It has a tiny land footprint, it's incredibly safe, and with these new technologies, it can be unlocked almost anywhere on Earth. For any country, this offers a real path to true energy independence. Which really leaves us with one final thought. For centuries, we've been fascinated by this idea of a journey to the center of the Earth. What if that journey isn't just science fiction? What if it's the most practical, most powerful path we have to a clean energy future for all of us?